Good afternoon. No, it's not afternoon, it's good morning. Good morning, you 13s. Right, guys, we know what we're doing today. We're going to smash through our weak acid homework. Mark that. You can log it on the score sheet. And then I'm going to... Sorry. It's gone. Can everyone do me a favor? Can you say hi on the chat? Just so I know that you're there. That would be grand. It's always nice to know that people are watching me. Right. Okay, guys. Share screen. Let's crack on. I'm also going to then turn off my camera because I have discovered, although I did that today in my year 10 lesson and my laptop freaked out, went blue screen on me. Went blue screen. Disable my camera. Uh-oh. Come on. Don't crash. Yes. Yeah. Weapon burning. Okay, guys. So we're going to smash through it and then I'm gonna kill off strong bases. Amazing. Right. Okay, guys, so your weak acid homework. Okay, so number one, explain the term weak in terms of acids. I'm going to do this in red. Explain the term weak. Partially, you're not allowed to write down not fully. Partially ionized in water. Ionized in water. There we go. Step number two, acid. It is a proton donor. Proton donor. Next, write an expression for, dichloroethanoic acid. That's cool, isn't it? No numbers needed because you can't go anywhere else. So, Ka expression. So the equation is this in equilibrium with CHCl2. What I've gone mad. CHCl2COOH. Now, you don't need to do this in the exam. I'm just doing it because, you know, I can, and it's worthwhile doing it. COO minus plus H plus. So my Ka expression is products over reactants. There we go. COO minus all over CHCl2COOH. We're done. Tick. 1 mark. Boom. I like it. So far. 1, 2, 3. Moving on. Next. Right. So it gave us now, 3 different people. 4 different people. Oh, that's clever. Oh, hang on a sec. Ethanoic acid is a weak vinegar. Successive replacement of the methyl hydrogen atoms by chlorine atoms gives. Right, there's 4 slots. Oh, that's a trap. I wonder how many people remembered. So, guys, it says to use the data book. Now, you guys don't get a data book any longer. You get a tiny one. But I was kind of hoping that you just look up their Ka values. I'd also like to think that you can do it without the Ka values. I have taught you how to do this. So we know that if you have a carboxylic acid group, the reason why this is acidic is because this bond here is already polarized. The electrons are down here, meaning it can break off fairly readily. Now, every time that you add a chlorine group, what that does is the chlorine is high in electronegativity, so it sucks electrons, the electron density out the molecule. Now, what that does is it increases the polarity. So 1 chlorine is going to move the electrons to here. 2 chlorines is going to move the electrons to here. 3 chlorines is going to move the electrons to here. Holy moly. So they're slowly becoming more and more polarized, which means it becomes weaker and weaker. More H pluses break off. So there's a nice, easy stages here in terms of weak to strong. So the first one is going to be ethanoic acid, just no replacements at all. Then followed by CH2Cl, COOH, and we're just going to get the successive removal of those methyl hydrogen atoms. And the final one, trichloroethanoic acid. Nice. That's okay. And it then says it's 2 marks. So that list there in order is 1 mark. That makes total sense. Only 1 mark. So if you get it in the wrong order, you lose 1. The strongest is trichloroethanoic. And the reason chlorine, I'll be good. I'll do it like I'm in an exam. Chlorine is high in electronegativity. It's high in electronegativity, which increases the polarization of OH bond, which means OH bond is weaker, so more dissociation. You can decide whether or not you want to give yourself that mark, guys. It's only 1 mark, yeah, but you can decide whether or not you want to give it to yourself or not. If you're not giving it to yourself, just make sure you make those adaptations. It's nice to see everyone giving me a wave on the chat, by the way. Thanks, guys. Next, calculate the pH of 0. Okay, so Ka equals, and this is just ethanoic acid. So H plus brackets CH3CO minus all over CH3 CHOH. Cool. Carboxylic acids. Right, 1 mark for that guy. Now we make an assumption. We make an assumption that the concentration of H plus and the concentration of the ethanoate ion is the same. That's the big assumption. We get 1 mark for the false. Actually, there probably isn't actually a mark for the false. Yeah, there won't be a mark for that. Now we need to input my numbers and reorganize. So the concentration of the original ethanoic acid multiplied by the Ka value will give me H plus squared. Oh, I can do this all in one go. Root answer. That's 1 mark. Input my data. Yeah, so I'm going to have 0.1. I don't like doing it like that. I'm going to do it just underneath it. So then 0.1 multiplied by, what was the Ka value? They must have given it to us. No, they didn't give it to us. You had to look it up in your data booklet, but I'm hoping that you guys know it. 1.7 times 10 to the minus 5. You should probably know that one by now. Root answer. That's going to give me the 3rd mark. So on with my calculator, 0.1 multiplied by 1.7 exponential minus 5. Root answer. 1 mark for this guy. 1.30 times 10 to the minus 3 minus log answer, and I get a pH. Minus log answer, I get a pH of 2.88. And I'm done. 1 mark for the final answer. So, that's interesting. That's 4 marks, and then there's an assumption. The assumption is the concentration of H plus is equal to the concentration of ethanoate ions. That's my big assumption. We're done. There's by the way, you could have also, there's actually 2 assumptions that are made. We're also assuming that the ionization of the ethanoic acid is negligible. Yeah, hence the 0.1, although you're multiplying it by the equilibrium constant, which takes it into account, but that is another assumption that technically we're making, and because that value should actually be slightly smaller. But anyway, but that's the major assumption. That's the one I want you guys to know. Oh my God, Ben just dabbed 3 times. That's amazing. I want to dab too. I just dabbed. Dab. Amazing. Loving it, Ben. Loving it. I'm loving it. Ethanoic acid and trichloride. So we now know that this guy is stronger than this guy. So we're going to have protonation. So we're going to have CH3COOH2 plus. And we're then going to have CCl3COO minus. If you want to see that in terms of a picture, here's what's actually happening. It's kind of cool, this. I always like doing this. So this is actually what's happening in the reaction. Yeah, this is now reacting with the H, there we go. It's reacting with the OH bond on the other guy. Now, because this is a stronger one, what happens is these electrons go for that breaks off, and that bond follows it over. Now, you guys don't need to know this. This is called proton transfer. So the final product is actually this guy. If you're interested, yeah, we now have a situation. Oh no. There we go. We now have this guy technically. And that the carbon is actually the bit that's fully positive, just so you know. It's just fun to see it. Yeah. And it becomes trigonal planar. Just to let you know that center now there is trig planar. Trigonal planar. Yeah, it's nice to mention that. Cool. So it's nice. Anyway, cool to see what's happening. Next, right now I need to spot your conjugates. So this is the acid because it's donating it to this guy. This is your base. And then, right, this is going to be the conjugate to acid. And this is going to be the C-base. Amazing. Take it if you got it. 2 marks. Boom, 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 boom. Moving on. Next, in which reaction is water acting as a Bronsted-Lowry acid? So the water needs to donate a proton. Donate a proton. C. There we go. because it started off as H2O, sending as OH minus, and it's giving a proton over to the ammonia, Bronsted-Lowry acid. Winner. Next, which of the following solution has the lowest pH? Oh, you've got to run them all? Ugh. The lowest pH. The answer is B. Don't even need to run it. We know that these guys are weak acids, so we scraps those two immediately. Yeah, and who's the strongest? Who's got the higher concentration? If you want to run them all, you can do. But I wouldn't even bother. You know that the stronger the hydrochloric acid with the higher concentration is going to have the lower pH. So it's B. Clever that. Write an expression for the Ka. Oh, Ka and ethanoic acid. It's a repeat. I like it. Good. This is why it's so important to go through these. Yeah, because it's repetition. It's designed to reinforce data. Reinforce good data. Next, calculate the pH of the ethanoic acid. So I'm just going to rearrange straight away. Root the concentration of the original acid, yeah, multiplied by the Ka value. I'm going to put Ka because they're going to want that. Gives me H plus. That's 1 mark for the rearrangement. Input my numbers. So root 0.125 multiplied by 1.7 times 10 to the minus 5. Final answer. 0.125 multiplied by 1.7 exponential minus 5. Root answer gives me a value of 1.46 times 10 to the minus 3 minus log answer. And I get minus log answer. Gives me a pH of 2.84. I like it. Second mark. Winner should actually be 3, really. Just letting you know. Yeah, there should be a mark for that guy as well. Next one. When half the ethanoic acid is neutralized, the concentration of the remaining ethanoic acid equals the concentration of sodium ethanoate, which has formed. What is the pH of the mixture at this point? Justify your answer. So we need to go. So what we know is that, just to do the understanding of this again, so the Ka is equal to H plus multiplied by the ethanoate ion. What they've then just done is they've just said that they have neutralized half of it. So then the concentration of this guy is going to equal the concentration of this guy. What that means is they disappear from the equation. So the Ka equals the H plus concentration. Therefore, pKa is the same as pH. Right. So all I need to do, pH is the minus log of the Ka value, 1.7 times 10 to the minus 5. And I'm going to get minus log 1.7 exponential minus 5. And I get a pH of 4.76. No, 77. Rounds up. Next, justification. Justify your answer. Oh, hang on a sec. So what we have to assume here? The assumption would be that there's no other acid in the mix, or there's nothing else removing the H plus ions. Oh, hang on a sec. No, hang on. You can't just say, oh, hang on. When the half of the ethanoic acid, the concentration of the remaining equals the concentration of that which has formed. What does the pH justify your answer? I'm just going to say pH will equal pKa. That's the justification. Yeah, it's literally me having run that. So that's my answer. That's really clever. Ha! Love that. If you want to check the mark scheme with June 2010, you can, but you don't need to because I'm awesome. In which of the following reactions is nitric acid acting as a base? Right, it's acting as a base. It needs to accept a proton. It's C. Yeah, definitely C for sure. Because look, the sulfuric acid is giving a proton over to the nitric acid, so it's acting as a base rather than acid. Clever game. You need to know that equation, by the way. The dissociation of ethanoic acid in an aqueous solution is represented by this. Oh, look at that. That is not the dissociation. That is the Lewis equation. Isn't that clever? Which of the following statements is true for this equilibrium? Ethanoic acid is an acid, and its conjugate base is this. That's true. Yeah, that's correct. So I think that's correct. Let's check the others are wrong. H2O is an acid. No, it's acting as a base. It's accepting a proton. Yeah, can you see that? It's gone from H2O to H3O+. It's accepted. It's acting as a base. So that one's definitely not okay. At equilibrium, the concentrations of each substance are the same. That's garbage, because we realize that the dissociation of this, we have 50,000 of these for every one of these. That's the most ridiculous thing I've ever heard, so that's garbage. At equilibrium, the reaction from left to right and the reaction from right to left have stopped. No, equilibrium's the reaction never stops. That's the whole point of an equilibrium. Yeah, that's the whole point of it being dynamic. Yeah, the forward and backwards reactions are always occurring. Next, why are aqueous solutions of sodium ethanoate slightly alkali? Ooh, conjugate bases. Why, hello there. It's because they can accept a proton. The sodium ion reacts with water to give an alkali. Well, that's just complete garbage. The ethanoic ion reacts with water to give hydroxide ions. Oh, that's probably correct. Yes, 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 yes. I'll go for you. All sodium salts give alkalis. Well, that's garbage. It's not explaining anything. The sodium ethanoate is fully ionized. That's just garbage. Whatever. So it's B. Just to explain that, yeah, the sodium ethanoate ion, I'm just going to shrink the pen down a little bit on this one. Yeah, so the sodium ethanoate ion is going to react with water. Yeah, this is going to react with H2O, and it's going to, let's actually do a mechanism. Oh, I love that. So we've got this guy, yeah, O minus, which means it has a lone pair. That lone pair is going to react with water molecules, and we're going to get proton transfer. Yeah, that's the mechanism. So it's going to form ethanoic acid and OH minus ions, and there's my base. Lol, that's amazing. It's a proton acceptor, guys, so it's got to be alkali. Yeah, that's really clever. So if I dump a whole load of sodium ethanoate, it's going to rip off the H plus, yeah, forming OH minus ions, so it's going to be slightly alkaline. That's really clever. It's going to have a pH of around about 8-9. Can we write as what? Oh, wow. That's a really interesting question. That was looking up this guy. You're wondering how to write that? You wouldn't do it like that, Dat. It would be CH3, C brackets, OH2, and the plus on the C. That's how it would be. I don't know why it's doing that funny thing with my pen. There you go. That's how you write it, that. You wouldn't do, yeah, weird. Anyway, I hope that helps. Next, smashing through weak acids. Come on, where are you? There we are. Right, let's keep going. Define pH. Minus log the height of the base 10 H plus concentration. Don't even need the base 10. If you haven't included the 10, don't worry, you still get the mark. Calculate the pH of HCl at 0.1. So because we know it's a 1-to-1, it's only 1 mark, so we only have to give the answer. But HCl fully ionizes in water, which means the concentration of this guy is equal to the concentration of this guy because it's a 1-to-1. So we just have to go minus log 0.01, and I get a pH of minus log 0.01. It's going to be 2. There we go. pH 2. Next. Ethanoic acid is a weak acid with a Ka value of, they've given us a different Ka value, that's on purpose. Calculate the pH of ethanoic acid stating one assumption. Right, calculate the pH of, okay, so I'm going to, Ka equals H plus multiplied by ethanoate ion all over CH3COOH, original acid, reorganize, root, I shouldn't do it, I don't like doing it, yeah, so therefore, Ka equals H plus over acid, CH3COO minus AH, sorry, OH. Therefore, root Ka multiplied by the original concentration of the acid, yeah, gives me H plus. Right, run it through. So Ka value 1.75 times 10 to the minus 5 multiplied by 0.01. Root answer gives me 1.75 exponential minus 5 multiplied by 0.01. Root answer gives me 4.18 times 10 to the minus 4 minus log answer. And I get minus log answer, and I get a pH of 3.38. And I'm done. Assumption, H plus concentration is equal to the ethanoate ion concentration. I like it. Moving on. Holy moly. In the case of hydrochloric acid, dilution factors of 10 increase the pH by 1 unit. Suggest why ethanoic acid behaves differently. Oh, God. Isn't that clever? Because you're not... Because, oh, it's going to shift the equilibrium. Oh, that's really clever. Wow. Guys, that's a bit weird, isn't it? Yeah, you're not going to get a standard dilution factor. God, isn't that clever? So hang on a minute. What's really interesting is look what's happened. So the hydrochloric acid has gone up by 1 point. It's become 10-fold less concentrated. So it's gone up by a pH of 1. This has become 10-fold less concentrated, but it hasn't increased the same. It's only increased by 0.5, by about half. So what's happening? In terms of molecules wise, that's super interesting. So if we just had H plus and Cl minus, if I, Joe, hang on a minute, I can do this in the same diagram. So if I had H plus and Cl minus, what we realize is if we double the volume, well, hang on, is that what they've done? Factor of 10. Yeah, so they've diluted it by a factor of 10. Blimey. So, lol. H plus and Cl minus, you dilute it by a factor of 10. You just have that same number of particles in that volume of fluid. But the thing is, with vinegar, it's not quite the same. The reason being is because the vinegar has to dissociate. Yeah, it has to ionize. Now we know that this is partial. CH3COO minus. And we know that this is partial and that there's an equilibrium here. And in fact, there's a reaction going on. So this is what's happening. It's actually reacting with the water in equilibrium to form COO minus and H3O plus. Now, if you add bulk loads of water, you're going to shift the equilibrium from left to right. So you're going to have more ionization, bringing the pH back down again. Oh, that's genius. Suggests why the equilibrium shifts from right to left, increasing numbers of H plus, increasing H plus numbers. And I'm going to write the equation as well. I feel like I want to. I feel like that could be a mark that. Yeah, I quite like writing that equation. It's really clever. So instead of getting a 10-fold dilution, you're not in reality. Yeah, increasing H plus number. So more H pluses reduces pH. That'd be really interesting. I want to see a mark scheme for that. What paper was that from? That was from that's from January 2011. Want to see that mark scheme for that? That's a really lovely question. Question 21. I really want to see the mark scheme for that. It's the first time I've kind of gone, oh, hang on a sec, that's interesting. Yeah, wow, there's a lot of questions on this booklet. I do want to see it. Blimey. Sorry, guys. It's uncommon for me to do this, but I want to see what they wanted there. So, and I also get to check my assumption. Can I show mathematically using Ka equation that include H plus and H3O plus? Oh, yes, probably that. I don't think they'd mind that. They're not going to like you very much, especially if the person marking your paper is not a very good chemist. Just warning you. Paper 3. What was the paper? Was it Jan 11? It was Jan 11 is what that was. That's really, really interesting. Jan 11 mark scheme. Question 21, right near the end. Let's see if we can track it down. Really, really clever. Question 21. Please be the right paper. 21. It's so not going to be the right paper, is it? Oh, no. It's not the right paper. I've not written down all the paper numbers. Oh, no. That was kind of the point of me doing that. There's the weak acid one. So many weak acid questions. I feel like, oh, that's so irritating. Oh, I'm going to have to track that down, guys. I will track it down. I will. Because that is the first time I felt like I'm probably going to get both marks, but I've got doubts in my mind. Which of the following is not a reaction of a Bronsted-Lowry acid and base? Like, so who's got no proton transfer? That's weird, isn't it? That's nucleophilic substitution, A. Nucleophilic substitution, that looks odd to me. Doesn't look like a direct proton transfer. I've still got that. I'll check the rest of them. So that one is definitely acid-base. Definitely acid-base. This one is definitely acid-base because the proton's being transferred over to that way. This way, the proton's going that way. The last one, proton is going that way. Definitely acid-base. The answer's A. I like it. Next. Information about the samples. Which of the following list shows the samples in order of pH? Oh, that's clever. In order of increasing pH. So who's the most acidic is that one. So 2 is going to be first. In order of increasing. Yeah, 2's first. I'm done. The answer's C. Let's just check. Yeah, because after that would definitely come HCl. That would be number 1. That would be the most. That's going to be like pH minus something, 0.3 or something. This is going to be pH 0. Yeah. HCl, that's going to be now pH 1. And this one's going to be, no, it's going to be like pH 2.8 or something. So that would make sense. So it's going to be, yeah, so from increasing pH. So, yeah, so 2, 1, 3, 4 is the right answer. C, I like it. Is there any others going in the other? Yeah, you see, D is the other problem. Yeah, it shows the samples in order of increasing pH. So we're increasing, yeah, as we move away. So C should be the answer. Next one, calculate the pH. So minus log 0.25, minus log 0.25. Calculator turned off. 0.25 gives me a pH of 0.60. Next, propanoic acid. Write an equation for it. Ka equals H plus, right? CH3, CH2, COO minus. So easily done. Students, by the way, at that point tend to write down the ethanoic acid one just by habit, because that's the one that comes up most frequently. Just like what I've done just then. I've literally been saying what I'm doing. Nightmare. There we go. Calculate the pH, 2 marks. I'm just going to rearrange really quickly, bring that over, root my answer. So root Ka multiplied by its concentration of a 0.25 gives me H plus concentration. So the Ka value is 1.3 exponential minus 5 multiplied by 0.25, root answer, and I get an therefore 1.8 times 80, 3 sig fig, 0 times 10 to the minus 3. Yeah, minus log answer, and I get a pH of 2.74. Next, we're nearly done, folks. I think I'm on my last page. Holy moly, it's taken longer than I thought it was going to take. My bad. Right, the Ka expression for the dissociation of benzoic acid. Oh, that's nice. Equals H plus, right, everything else left. C6H5COO minus, all over C6H5COO. OX. Use the data book to calculate the pH. Oh no! I've got to look up its Ka value. Darn it! Use the data book answer to suggest why the bubble bath changes color. Ooh, isn't that cool? The bubble bath color change matey has amongst its ingredients ethanoic acid. As a result, as the indicator Bromo crescel green, which is added to the bath water. Its color changes from yellow to blue. Wow, that's neat. So I'm going to have to work out its pH at that concentration. So I need to look up benzoic acid. Ooh, let's have a look. I'd hope you did the same thing. Benzoic acid Ka value. That's what they'll tell you in the data book. 6.46 times 10 to the minus 5. Good, okay. That's all right. I'll take that. 6.46. Yeah, 6.46 times 10 to the minus 5. So multiplied by the concentration. Yeah, root answer will give me H plus concentration. So 6.46 exponential minus 5 multiplied by 0.0025. Root answer, it's very dilute. Gives me an answer of 4.02 times 10 to the minus 4 minus log answer. So I've got a pH of 3.39. No, rounds up, 4.0. Right, now that's really clever, that. So what's going to happen is, when you add this 4 marks, holy guacamole. Question 10, it says below the question, because you're adding more water. Oh, would it not shift the equilibrium to the right? Oh, I'm sorry, I made a mistake. Thank you, Emma. Right to, left to right. I'm sorry, I literally did exactly that. That's left to right. I'm so sorry, I made a mistake. Shifts the equilibrium from left to right. I did know what I was doing, I promise. I just wrote down the wrong thing. I'm so sorry. Left to right. Thank you, Emma. Yeah, what does the mark scheme say? Doesn't we'll find it. Because you're adding more water. Jan 10, it says below the question. Oh. Oh, yeah. I'm an idiot. I wonder what it says on the equilibrium. What it says on the mark scheme. Someone can look that up for me. I'm running out of time. I've got to do strong bases as well. I'm going to do strong bases in 20 minutes. Amazing. Use the data in the data book. Right. So, guys, that question that we had previously would be really interesting. So what we know is, if you have a bath bomb, yeah, and that bath bomb has a pH of 3.4, pH of 3.4, you're going to add this to a bathtub of water. You're going to dilute this exponentially. Like, you're going to be diluting it by just such a mammoth amount. The concentration's going to plummet, which means the pH is going to increase. So, first mark, adding to bath dilutes, God, I want to look the answer up to this one. Bath dilutes the acid enormously. I think there's going to be some enormously. There's going to be some kind of thing on the mark scheme that says diluting a lot. Yeah, words to this effect. You are correct. An alternative method is my method by showing it mathematically. I hate mathematically that, but okay. Fine. Adding to bath dilutes the acid enormously. Therefore, the pH will increase. Yeah, increase. So we're going to go from pH 3 up to something like, God, at this dilution, we're going to be heading close to 7, guys. Like, holy moly, that's going to be crazy. You're going from a bath bomb of volume, like maybe like 200 centimeters cubed. You're adding it to meters cubed, like half a meter cubed of water. This is mental. Yeah, you're going to have a big pH. Now, so the pH will therefore increase. Now we have to look up the color change for Bromo Crescel Blue, Bromo Crescel Green. Let's look it up. Love this. I'm really enjoying this question. This is my favorite one so far. So it's going to change. So this is Bromo Crescel Green indicator. pH range. Yes, please. Right. And where is it? There's my data. Love it. I'm loving it. Bromo Crescel Green. Oh, and there's its range. 3.8 to 5.4. I like it. So it's clearly in at the beginning, yeah, at pH, the pH will increase. At pH 3.4, Bromo Cresel Green is green. Color changes. I'm just going to check my thing on my little thing. It is green. Yeah, it's green. Green. However, it changes its pH range. However, its pH range for color change is 3.8 to, what was it? 5? 3.8 to 5.4 to 5.4. So diluting this much increases pH above 5.4, so color definitely changes. Yeah, that's cool. Definitely changes blue. I love that. That's brilliant. Want to see that mark scheme? Holy moly, do I want to see that mark scheme. That's so cool. I'm such a nerd, aren't I? I'm so sorry, guys. I am I am like a super nerd. So sad. What was it? What paper was it? Jan 12. Jan 12. Can I just point out what an amazing question that is? I absolutely adore that question. The data booklet says it's yellow at 3.4. Oh, okay, cool, fine. That's really interesting. Well, my internet says differently, but I'm okay with that. Bromo Crescel Green. Hang on. Was it Crescel Green or Crescel Purple? Because there's loads of Cressels. There's loads of Bromo Cressels. There's two Bromo Cressels. Bromo Crescel Purple is yellow. Bromo Crescel Green. Oh no, they look kind of similar. But bromothiamyl. Just check that you're looking at the right one, Emma. Check you're looking at the right one. I want to see that. That's absolutely. I love that question. Oh, it's just made me so happy. The pH range of the indicator is 3.8. Yes, nailed it. Let's mark my answer. I love marking my answers. 3.8 to 5.4. Next, the bath. Bubble bath is initially yellow since pH less than this. I like it. So, and it will increase. So diluting this much, color change definitely turns blue. I didn't mention the original color, did I? No. Original color. pH. Oh no. I meant to say it here. That's what this was. At pH 3.4, Bromo Crescel Green. Bromo Crescel, I was meant to say is green. I'd lose the mark, definitely. It's vague. And obviously the exam says yellow. The data book says it's yellow. That's fine, Emma. They're giving you a different answer from what... I mean, let's be fair. The internet's a great resource, but it's also full of darn it, just closed that tab and I wanted it. Let's bring it back. I'm not going to get to strong bases, am I? Reopen, close tab. I've got a feeling it's totally mine. It's going to be yeah, there you go. Bromo Crescel Green. Yeah, there you go. It's garbage. It's just the internet's full of rubbish chemistry. Yeah, so, yeah, you're absolutely right. That's the internet's useful, but it's an absolute nightmare. There you go, yellow. That's absolutely fine. Cool. I nearly got it, but I wouldn't say I gave it. I'd want to make that clearer in my eyes. Yeah, original color. What's the next mark for? What the next mark is adding water dilution causes pH to rise. Hence, pH rises to greater than 8.4, definite color change. I love it. What an amazing question. Oh, EdXL, I salute you for that question. That was some seriously sexy chemistry right there. Whoa! Shut up, Alexa. Sorry, guys. Alexa's chiming in. She shouldn't be. Lol. Right, guys. That was an epic homework. I don't even know how many it's out of. Okay, I'm going to add it up, and it is on the tracking sheet. Let's add up the marks for this, because that was a big homework. I'm so sorry. That was big. 5 marks for the first page, and then 6 marks for the second page, and then 7 marks for the third page, and then 3 marks for the fourth page, and then 6 marks for the fifth page, and then 3 marks for the... I'm so sorry. 5 marks for that page, and then, holy moly, this was a long exam. I'm so sorry. 7 marks. Wow, guys, that was hard work. Let's add it all up. That was a big thing. That on 5 plus 6 plus 7 plus 3 plus 6 plus 3 plus 5 plus 7. Holy moly, that was out of 42 marks. Yeah, okay. It's out of 42, guys. Oh, yeah. Wow, that was epic. Guys, can I just say, I'm not that took me a while. Well done for you guys cracking on. If you can fill in your scores, that would be grand. Well done. What an amazing effort that was. That was really challenging. I really enjoyed it, and I definitely didn't get full marks either. I reckon I lost 2 marks. 1 because I got the shift backwards because I was being an idiot, and 2 because I didn't mention the color. I'm going to be mean on myself and say I should have said is. I think the is. If I put is, I would have given myself it, but I didn't. There was doubt. I wouldn't get it. So you can fill in your scores. Guys, what I'm going to do now, I'm going to end the YouTube video now. I'm going to do strong bases. Next lesson, I've just closed a tab again. So my laptop is being rather irritating. Reopen, close tab. Yeah, okay, there we go. Right, I'm going to bring this back. Oh, no, can't do that because I've disabled my camera. Lol. Let's re-enable. Enable camera. And see if my laptop crashes. There we go. And then start cam. Is it going to freak out? It's given me the backward one. That's hilarious. Camera. Let's go front. There we go. I'm back. Cool. Guys, I will leave you there at that point. 40 minutes. That was a tough homework, that, guys. I'm really, really proud of you guys for getting through it. I know it was difficult. It's nice to see marks going in. Not only that, not only marks going in, but outstanding marks. Well done, guys. Yeah, I hope you find them useful. I'm really, really proud of you because those are real exam questions. These will make you better chemists. You will get better grades by doing these homeworks. Every homework I am making for this topic is just literally me going through all the exam papers and ripping out all those calc types. Next lesson, we'll do strong bases. You have no homework to do now because I haven't done the theory. I will do strong bases next lesson, and I will see you guys then. So guys, have an amazing rest of your day, and I'll